So for scenario two, there's 95% water outside the cell, 91% of water inside the cell. So what that tells me is that there's just a higher concentration of water outside the cell compared to inside the cell. All right, now even though that's the case for my solute, there's more solutes inside the cell compared to the outside. So I have a high solute concentration inside the cell and a low solute concentration outside the cell. All right, so what I realize I have is I have a concentration gradient for both water and solutes. So let's just focus in on water. And remember that particles are always going to want to move from a high to low concentration. So the water is going to move from a high to low concentration. Now keep in mind some water molecules still might leave the cell, but overall more water molecules are going to go inside the cell. So if I look at my solute, I still have a concentration gradient where there's a high concentration of solutes in the cell compared to the outside of the cell. So these solutes want to move from a high to low concentration. However, if we look, it says that this cell membrane is not permeable to these specific solutes. So even though these solutes want to leave the cell, they can't. So overall what we have is solutes want to leave the cell, they can't. Water does want to go into the cell, it does. And because water rushes into the cell, my cell is going to swell.